All right, so this is our world right here. We're starting to figure out all that SLO and SLI stuff. And when a team blows their error budget, you probably get into a war room to figure out what happened. Maybe you hold an incident review. And then you have to rethink whether those SLOs are even accurate and what your tolerance for failure truly is. SLOs and error budgets may have become the most important items in the SRE toolkit. So who here has actually implemented them? Show of hands. OK, and who, if you were just getting started, SLOs would be like the first thing you do? All right, so I think that accounts for pretty much the whole room. SLOs have transformed how we think about prioritizing reliability. And we've created this way that helps us keep steering teams back onto a happy path. SLOs have given us a framework to realize just how important failure is. In fact, failure is so important that it's no longer interesting. If all we're ever doing is engaging with people when they're having incidents or blowing their error budgets, we're missing out on this whole other world of opportunity. We need to start realizing that the other side of failure, success, is at least half the story, and we've been ignoring it. My name's Ryan Kitchens. I work on the core team at Netflix. We are responsible for ensuring availability, and we focus on the incident lifecycle. This talk is structured with some ideas, a few models that explain them, and then I'll talk about the things that my team does to learn more about incidents. We've heard folks like John Alspaugh talk about some of this stuff before. My team is implementing it into real practices. I want to start by highlighting some principles that kind of set up the place we need to be coming from in order to learn more. And maybe they're more like opinions, but they're totally correct. That's how opinions work. It's really hard to point out this stuff without sounding dogmatic. Buckle up. What I want to get at isn't that anyone's doing it wrong, but rather that we can step it up, dive deep, and practice more effective ways that go beyond failure prevention, because failure is the normal state. We've heard from Dr. Richard Cook that the surprising thing isn't that our systems sometimes fail, but that they ever work at all. What if I told you that the reason you're having incidents is because you are successful? And you're going to have incidents. You can't choose not to. Oh, well. But here's the thing. We're pretty good at preventing them. All those times we aren't having incidents, that's called normal work, and it's successful most of the time. We're never going to be able to prevent them all. That's too bad. One of the biggest tropes out there is, how can we be more proactive and prevent this from ever happening again? That's not helpful. It's superficial. The word proactive is so often lip service. It may sound counterintuitive, but overly focusing on preventing incidents will end up preventing fewer of them. Preventing incidents is going to happen. We do it every day. Don't pretend to focus on that as your goal. The goal is to learn. The most important thing we can learn is how to build the capacity to encounter failure successfully. We should be getting to a place where it's okay to say, that's exactly the kind of incident we want to have. No action items necessary. So here's a secret. This is what chaos engineering helps us do. Once all the low-hanging fruit is gone, once your detection time is down to seconds, once you have a way to fail out of multiple regions and remediate in a matter of minutes, how do you think about getting proactive then? The nines don't matter if users aren't happy. Thank you, Charity Majors, for talking about this. I want to take it a little bit further to say also, availability is made up. Even the margin of error that goes into capturing it's bigger than the next 9 you're trying to report on. If you're spending any significant effort creating availability reports, I think you should probably stop. The availability you have is probably fine, because we don't define success by the absence of failure. It's the presence of adaptive capacity. It's the ability we have to cope with the things that are changing around us continuously. And there is no panacea. We know we can't just do DevOps or start calling people SREs or put SLOs on everything and expect it to solve all of our problems, except for expertise. The game changes when you start to realize that the people on your team are the world-class experts for your systems. Right now, you work with the best people on the planet for encountering the problems you're going to face, and they're already preventing them every day. Imagine what can happen when they start to be taken seriously on this. Remember that region failover thing we do to remediate our problems? What do we do when that fails? And more importantly, are we even paying attention to what happens during all of those times it doesn't? Okay, so there's one more really big idea I'd like to see more of us advocating for because it absolutely changes the conversations we have about learning more from incidents. There is no root cause. The problem with this term isn't just that it's singular or that the word root is misleading. There's more. Trying to find causes at all is problematic. And root cause, debatable? Going in looking for causes to explain an incident limits what you'll find and learn. And the irony is that root cause analysis is built on this idea that incidents can be fully comprehended. They can't. And we already have a better phrase for this, and it sounds way cooler. It's called a perfect storm. In this way, separating out causes and breaking down incidents into their multiple contributing factors, we're able to see that the things that led to an incident are either always or transiently present. An incident is just the first time they combined into a perfect storm of normal things that went wrong at the same time. So I'd like to remind us about the themes at SREcon this year. Comprehension, understandability, predictability. In a complex system, none of these are entirely possible. Incidents cannot be fully comprehended. They're fraught with uncertainty. And often, we find that the remediation items coming out of incidents contribute to further incidents. This realization is kind of a big deal. Action items won't save the day. There are organizations out there who require high-severity action items following every incident. Really think about the consequences of that. And you're not gonna avoid big incidents just by dealing with a bunch of smaller ones. It sounds intuitive, but it just doesn't work that way. Like logs filling up on a server, probably not gonna take down your whole business, right? Is anybody thinking like, I don't know about that. I should let you know, my team's hiring. Sometimes we do that kind of stuff on purpose. So the little stuff doesn't cause the big stuff. And suggesting that causes are the keys to understanding an incident is misleading. Causes are something we create and construct afterwards. They aren't a primitive that make up incidents. They don't fundamentally exist to be found. There are so many aspects to incidents that aren't even causes at all, and they don't follow a linear chain of events. You're never going to be able to predict the next incident no matter how much you learn from the previous one. We're pretty good at preventing incidents. We're terrible at predicting them. The state of the system's changing around us all the time, no matter how immutable we try to make it. So Laplace's demon is this person who knows the precise location and momentum of every atom in the universe. Complex systems are not deterministic, so why do we think we can foresee all of the consequences of our actions? Why do we think we can maintain an accurate mental model of the system? Why do we think we can avoid every mistake? Why? It's kind of the wrong question. In hindsight, so many actions look like a choice. Why'd you do that? Can make people feel blamed. Instead, what we want to do is enable people's stories, draw out descriptions of what they did, and facilitate in what ways it made sense at the time. You get that by asking how, more so than why. And the 5 whys is limiting. I'm not going to say you're doing it wrong. I'm not criticizing anyone who uses the technique. It's useful. But because this is true, you're gonna miss stuff. Each why we go through dismisses more and more available information, and it can lead us to think we've totally understood an incident by following this path of why things went wrong. So an example of this, an engineer was deploying a hotfix. They bypassed all the safeguards, and they ended up breaking stuff even more. So when we asked them, well, why'd you deploy it like that? The answer we ended up at was, well, I felt rushed and stressed, and I probably should have slowed down. Okay, so following the whys, we kept hearing a lot of self-blame, and we were missing what those sources of pressure were about. When we asked them how they went about deploying it, they told us a story about coordinating on call, diagnosing the problem, and how the changes were implemented. So instead of getting at what they thought they should have done, we started to get to the point of how this actually happened and what conditions allowed it to. At this point in our field, we gotta kick it up a notch. There's no one weird trick that's gonna work. We need to start realizing that the other side of why things went wrong is understanding how things go right. I've seen organizations where management is incentivized to drive down the number of failures. This is a fool's errand. Trying to prevent all failures isn't as effective or realistic as successfully minimizing the consequences of that failure. Eventually, you're gonna max out on how much you can do to prevent things from going wrong. At some point, the complexity of the system won't let you. And if you try, you're only going to introduce more peculiar modes of failure. We don't increase our success by trying to prevent things from going wrong. We do it by making sure that things go right. And people are doing this all the time during their normal work. So I'm going to run us through this model of how we can end up at either path, success or failure. This scary sounding stuff called performance variability. That's the reason behind how everyday work is safe and effective. And it's also why things sometimes go wrong. But what is it? People adjust what they do to match the situation. It's the improvising and workarounds that people are doing so routinely they probably don't even notice it. Think about all the times you're making small configuration changes, adjusting thresholds, dealing with auto-scaling. Through understanding the variability of everyday performance, we find that the things that contribute to failure are the same things that contribute to success. People are doing the same things in both cases. It's only the outcomes where we start to make these judgments into our trade-offs, shortcuts, and workarounds. You might remember this helicopter rescue in the French Alps. This happened in January. It was awesome. The helicopter flew right up to the mountainside, into the snow. People jumped on the helicopter, they flew off, and everything was fine. So I realize this might not be normal work for most of us, but for rescuers it kind of is, and it was a pretty big success. But let's imagine it wasn't. In the case of an accident, we usually expect this deep investigation that could unearth all kinds of stuff about what happened and how it happened. But since everything went fine, we ignored all that. It's pretty hard to ensure that things will go right next time if we aren't learning how things go right in cases like this. So when we have an incident and the response is more testing, higher guardrail, stricter process, we have to ensure that we aren't limiting the opportunity for our expertise to come through, because constraining performance variability in order to remove failures will also remove successful everyday work. So what I'm trying to say is, what if the real success was the incidents we made along the way? So this is how people talking about the new view or safety two tend to model the problem. We tend to focus on that small amount of time we run into failure. But what about most of the time when things go right? And just to show you that this holds up in reality, this bar is a breakdown of a few years' worth of actual availability data from a real customer-facing service. So why are we talking about failure all the time when all it is this teeny tiny bit of red? If we want to focus on learning more, we need to be considering all of it. We love to talk about data. Learning from how things go right uses most of the data available. This gets us back to the pitfalls of the 9s. Emailing them around to feel good is really kind of a lie. And it doesn't capture everyone's use case of what availability is because everyone cares about a different part of that availability. It's almost like people just want to know that it's out there somewhere and somebody, thank goodness, is thinking about it. So next time, publish that number in a Google Doc, something people actually have to take effort to click on to get to. Check the analytics on it and see how many people actually looked at it. What's more effective is to think about all the different dimensions that go into creating that number. There are a ton of qualitative measures that are worth way more than the percentage point they represent in the 9s. If availability is made up and the 9s don't matter, then putting incentives around these numbers is worse than meaningless. It's parasitic. It's not making you better. So to repurpose a phrase I've heard in security recently, I'd also say that availability is perceived. So why point this out? Why am I harping on this? It's because the green part of availability that we call success, that huge portion of stuff we've been ignoring, it's at least half the story, and it's often invisible. This is fundamentally what we are up against. I can't tell you about the incidents we didn't have. Measuring stuff like the number of incidents or the probability of failure, that's something we're generally able to do. But how things went well, the probability of succeeding, we usually don't try to understand all the things that contribute to all those times we aren't having incidents. This is why it's so important to develop holistic techniques to learn more, to help tell the whole story, because what went wrong is at most half of it. So we might want to think about how do we keep normal work normal and keep incidents weird? So this starts to bring into question, what's the criteria for an incident? Well, here's what it looks like when you file one. Who here tracks the severity of their incidents? Who regularly reports on how many Sev1 major incidents you have? So just like availability, I think we should stop doing this. Those broad categories don't help surface patterns across incidents. It's not good enough to get up at your quarterly business review meeting to report, we had 10 Sev1 incidents this quarter, and here's how it compared to last quarter. That doesn't mean anything. It doesn't gauge customer perception, and that sentiment focuses too much on preventing incidents. You're not getting better just because fewer incidents were reported. So the gist of our incident here is that the website got a burst of traffic, users saw errors, and people were unable to sign up during this time. So pretty straightforward. But how do we get more out of it? Where do we go to get beyond why things went wrong? So we can start by making the description a little more explicit. Like, what did you actually do when you got paged? So signups were down. How did you figure that out? Did you get another alert? Did you have to dig for it? What's a death spiral? Other people might not know what that means. So customers saw errors, but what was the impact of that on your customer service team? How did they handle it? What did they see? And something we tend to forget is what mitigated the incident? How did we escape that death spiral? What happened to that burst of traffic? Where did it even come from? So what's next? This is an outline of what my team goes after during an investigation. And we have Nora Jones to thank for coming up with this. My colleagues, Lauren Hochstein and Ashish Jotwani, have done a ton of work here. So start by taking everything you think is a cause and separate it out, and then explore each and every one of them. Talk about the properties and the attributes that were present. You're going to unearth so much more this way than trying to walk back a linear chain of events of this led to that. What kept the incident from being worse than it was? This is the hardest part because of the way success is often invisible. So get everyone calling out all the things they saw work that helped stop larger problems. We think of risks as more general things that can create danger. Some examples would be like bulk updating things globally or unbounded queue links. In the case of this incident, here's what we can turn them into. There are about 8 items per section here. And just to zoom into them, in our investigations, each one of these items has a paragraph to go with it. Sometimes they spark even further investigations. So we could have stopped at, oh, auto-scaling took care of it, and things kind of recovered on their own. But there were so many things going on here. These seemingly simple incidents often make the best examples of how to do this kind of work. Even out of a small incident, we can start big conversations, change the way teams interact, and surface things that aren't on anyone's radar. This last one, unexpected performance from upgrading to new instance types. Upgrading instances was one of those remediation items from a previous incident that contributed to this one. We really do see this happen. Difficulties in handling can be things like, did we have to page in that one specific person because only they know how to fix it? We call this the islands of knowledge problem. You might not realize until later that there were problems collaborating. Like maybe we don't agree on what a small blast radius is, and we could affect many more customers than we would expect. Action items are not the point of doing all this stuff. Fixing stuff, if someone thinks it's important to fix, they're going to fix it regardless of whether or not you write it down. So here's a different way to think about it. Can we identify actionable outcomes? Or did we unearth significant new information that would allow us to revisit big design decisions? Artifacts are the output of an incident, like documents, reports, tools, saved queries, dashboards. Consider the long-term velocity. How can we use these for education? How do we get this stuff informing other teams' roadmaps? It's hard to assess these in ROI terms. A lot of effort goes into creating them. They live for a really long time, and hopefully people are doing things with them. To find out what, you can check out J. Paul Reed's Lund University thesis. This was just published. Very good read, talks all about this stuff. I'll have references in the slide at the end. I'd also like to see some better timelines. What if we could explore them or filter on them, highlight observations, how working theories played out, rather than this two-column table? What if we could map it? What if our timelines looked more like this? If you can make something like this interactive, timelines will become a point of engagement instead of an appendix referenced at the bottom of a document that nobody's going to read. Be sure to link out to all the stuff that happened: pull requests, commits, code reviews, deployment times, system changes, graphs, anything that can help add more context. And get the easy questions out of the way early. The more preparation you do, the deeper your discussion can be during an incident review. So people's first reaction to seeing this kind of stuff is like, well, I don't have time to do that. So start to think of incidents as unplanned investments. The more you do it, the better you're going to get, and you'll start to realize what kind of incidents are worth going after in this level of detail. We don't do all of them this way. So I hope that's a fairly practical breakdown of what my team does during an investigation to get more out of incidents. But what about when we don't have any incidents at all? Have you ever considered what's going on when it seems like nothing's happening? How hard are people working just to keep the system healthy? You can't detect this kind of stuff with availability data or error budgets or number of incidents. There's an irony here, and it's the big blind spot of SLOs. So a question to managers: how do you think about feeding this back up the chain? Or do you not, because everything looks good? You can have awesome availability. All the usual signals can be green, and a team can be right at the edge on a path to burnout, and we'd never know if all we're doing is paying attention to when they're having incidents or blowing their error budgets. This is an incredibly expensive problem. I don't just mean money cost. This is how churn happens. It's how good teams dissolve. So how do we sort through it when all we have are weak signals? I think it involves facing the hardest problem that's probably ever existed in tech. You have to talk to people. There's no getting around this. Gosh, how much stuff have we built just to make it so that we don't have to talk to anyone to do our jobs? So get out there and interview people. Maybe we should call it something different. Interview sounds intimidating and time-consuming. Like, sure, we could chat, but oh, I don't know if I have time to be interviewed. You also don't want to look like you're FBI or internal affairs. It's not an interrogation. We're not making a murderer. So try to get out of the conference room. Go on a walk with people. Grab some coffee together. There's also this thing called learning teams. This comes out of the Human and Organizational Performance, or the HOP movement. You can check out Andrea Baker's work for more on this, but the basic idea is you take some event, it could be an incident, it doesn't have to be. You assemble a working group of people from different levels across the organization, and you bring them together to answer one question. What can our organization learn from this event? Building a learning organization is a real way to be proactive. That's how you actually prevent incidents. So how do we do that? Start by asking better questions. I'd start with, are our people okay? What were you really worried about during the incident? Did you feel supported? What could have happened? What do you think could stop that from happening? Is that enough? Could this happen to anyone else? Going back to our interviews, asking better questions helps construct how we got here. Talking about deployments, we can ask, how do you usually gain confidence in these kinds of changes? Do you do code reviews? Are there canaries? Is there progressive delivery to production? Is this a typical change? Did you use a pipeline? Was it a one-off? Were there any workarounds involved? What was preferable about doing it that way in this case? We learn so much more when we start to understand how a course of action seemed reasonable at the time they were taken. It's easy to see what happens after an incident is triggered. It's much harder to uncover the events leading up to one. It sure is quiet before an incident, like maybe nothing is happening. The things we're adapting to get hidden by the very actions we take to ensure that they don't become problems, until one surprises us. And how we respond to that surprise is really important. Be more careful is never helpful advice. Carelessness or risky behavior doesn't cause incidents, and it's only afterwards that we're even able to judge it that way. Best practices are not real practices. I don't want to talk to only the people who are engaging in risky behavior and breaking things. I want to talk to people who are doing risky things all the time and not breaking stuff. What makes them so successful? That's where you'll find your real practices and learn from how things go right. So it can be difficult to deliver this message with compassion and sincerity. You're always going to have someone asking, have you tried not writing bugs? What if we just didn't have errors? Why didn't you just do this other thing? Don't vilify them. It's better to demonstrate how inefficient those kinds of comments can be. So here's some of the material to help us with this. The Field Guide to Understanding Human Error is a great intro for anyone. This paper, Language, Bias, and Accident Investigation. If you don't think language matters and the words that we use influence how effectively we learn, this paper will change your mind. If the hardest problem in tech is talking to people, then words are like the second hardest problem. And there's one word I'd like to change. Incidents are surprises. Can we all start calling them that? To review the takeaways, build capacity to encounter failure. Recovery is better than prevention. There's no root cause. Stop reporting on the nines. It's not making you better. And learn about how things go right. At this URL, which is jobs.netflix.com, you can find more. All of the references that are in this made up the slide deck, you can get at this URL. It'll link you to a GitHub repo. Please send me a message on Twitter. I would love to talk to all of you more about this. Thank you.